Assalamualaikum warahmatullahi ta'ala wabarakatuh. Welcome to another video on signal and system analysis, where in this video I'm going to show you the solution to example number 3 of chapter 1 for our course. Okay, so in this question we are asked to determine the fundamental period, fundamental frequency and the angular frequency, okay, which are T naught, omega naught and f naught and omega naught, okay, for this given signal g of t. And we can see here g of t is consists of the sum of sine wave and cosine wave. Okay, so therefore the first thing that we have to do is we have to find the fundamental period for this signal, sine signal, and this cosine signal separately. Okay, and then we are going to use the mathematical theory called least common multiply. So I have teach you this in class, and also it's available in your handout. Okay, the least common multiply to find the T naught, which is fundamental frequency of g of t. Okay, so how do we do that? So first, let's assume this sine signal to be g1 of t. Again, and let's assume this cosine signal to be g2 of t. Okay, right. So let's write back g1 of t equals to 10 sine 12 pi t. Okay, and again here we are going to write the general equation for the sine function. Yes, it's available in your handout. I believe page 16, equation 1.5. So here it will be a sine omega naught t, right? So what you wanted to do next is make the terms in the bracket here to be equal so that we can calculate for omega naught. Okay, so if we do that, we have omega naught t equals to 12 pi t, right? Therefore, omega naught will be 12 pi t over t, right? So this t cancel out, so we get 12 pi radian per second. By the way, I think I'm just going to make a little bit modification here. Okay, I'm going to write this as omega 1. Okay, because this one we're calculating for g1. Okay, and therefore when we calculate for the fundamental period for g1, okay, so we are going to get t1, okay, equals to we have the relationship between fundamental period and angular frequency. So t1 is equals to 2 pi over omega 1. Again, you can look at this equation in your handout. Okay, I believe it's it's page 17, okay, of your handout. So here you will get 2 pi over 12 pi. So this will be 1 over 6 second. Okay, and let's do the same for g2. So here g2, if we write it back, we get g2 of t equals to just bring this up, 4 cosine 18 pi t. Okay, so next we wanted to write back the general equation of a cosine function, which is a cos omega naught t, right? So again, what we wanted to do is make the equation or the terms in the bracket equal so that we can calculate. So again, here let's put it omega 2, so we can calculate for omega 2. So we are going to get omega 2 t equals to 18 pi t. Therefore, omega 2 is equals to 18 pi t over t. So you're going to get 18 pi radian per second. Okay, so then we get omega 2, so we can calculate for t2, which is 2 pi over omega 2. So it's 2 pi over 18 pi, so we get 1 over 9 second, right? So now we get two numbers, which is 1/6 and 1/9. So the next thing that we wanted to do is we wanted to calculate for the least common multiply. Okay, we wanted to apply the least common multiply mathematical theory to solve for the fundamental period of g of t. Okay, so now we have two numbers, which is 1/6 and 1/9. Okay, so if you remember from our lecture as well as in your handout, so I told you when we have non-integer number like this, so the first thing that you wanted to do is to multiply these two numbers with a common number so that they become integer. So in this case we have 6 and 9, so the common number that we can multiply them with is 18. Okay, so that they become integer. Okay, so this cancel out, become 3. This cancel out will become 1. Okay, therefore here we are going to get sorry, not 1, 2, 3 and 2. Okay, so the next step, as I explained in the lecture, is to find the prime factor of these two numbers. But in our case here, 3 and 2 are already prime numbers. Okay, so we don't have to reduce them further. So here is 3 and here is 2. So these are already prime numbers. So we can directly calculate the least common multiply for these two numbers, which is in this case 3 and 2. So it becomes 6. So the least common multiply for these two numbers 6. However, this is not the fundamental period of g of t. Okay, because g of t, the fundamental period, to calculate that, we take the LCM here. And remember, here we multiply this number with 18. So here, to calculate t naught, we have to divide this number, okay, with 18 again. Okay, because here we pre-multiply. Okay, over here we pre-multiply the number with 18. Okay, and then we calculate the least common multiply. So to get the fundamental period of g of t, okay, we have to divide this LCM number with the number that we pre-multiply from here. Okay, so in that case, this will become 1/3 second. So this is t naught, okay, which is the fundamental period of g of t. Okay, this g of t, which is the sum of sine signal and cosine signal. Now that we have t naught, so we can calculate f naught, which is equals to 1/t naught. So in this case, equals to 1/1/3. So it becomes 3 hertz. Right? And then omega naught, we know that it is equals to 2 pi f naught. So 2 times pi times 3, then it's 6 pi radian per second. Okay? So these are the fundamental periods, fundamental frequency and angular frequency of g of t. Okay, which is the sum of a sine function and a cosine function given in the equation over here. Okay, so I hope it's clear how to solve this type of problem. Okay, so the purpose of this problem is for you to practice on using or on applying the least common multiply theory. Yeah, so with that, I end the video here, and I see you again in another video for another example. Thank you.